All right, welcome back to the deli. Hungry? Stop by the deli. Get yourself a sandwich. Today's drive-through confessionals feature 10-8, number 18. They ask for us to find, in part A of it, to find, let's see, WY. We're trying to find WY. All that we know is that the radius of each circle is 3. Now, it's hard to draw this picture, but imagine that being a tangent segment. That makes that a right angle right there. It does tell us that this red triangle is an equilateral triangle. So, if I was to draw this blue triangle, it's a 30, 60, 90 triangle. There's your 30. Okay? That makes that 60. The radius is 3. So to get from the short leg to the long leg, I multiply by radical 3. So that makes this 3 radical 3. If I did the same thing down here, that would be a right angle. That's a better picture. This would be 30. This would be 3. So those are congruent triangles there. That makes this 3 radical 3. And that is 3 radical 3. So now what I need to do is to find some other distances. Well, right here, that's just a rectangle. And that rectangle is 3 by 6. So that's 6 there because this is a radius and that's a radius. And 3 plus 3 is 6. Same thing here. There's 2 radii right there that I just drew. That's 6. So WY in part A, WY is 3 radical 3 plus 3 radical 3. That's 6 radical 3. And there's 12 more. And that's as simple as we can write that. That's like 6x plus 12. We cannot simplify that. So that's the answer for part A. Part B says, find the ratio of the perimeters of A, B, C. So that is this. ABC, so green, to PQY, which is this one, to blue, to red. Find the ratio of their perimeters. Well, I don't think I need to find the perimeter, because if I find the perimeter, I'm just going to divide it by 3 anyway, because these are all equilateral triangles. So I'm just going to find the ratio of their side lengths. You might remember that the ratio of their perimeters will be equal to the ratio of their side lengths because they're similar. So let's start with the red because we already have that side length. That is 6 radical 3 plus 12. Okay, the green perimeter, well, this is going to be 3 and 3. So that's, we're going to call the side of the green 6. And now we need to just find the blue. And that is 3, 3, 3, and 3. And that makes 12. So it's 6 to 12 to 6 radical 3 plus 2. As a ratio, I can simplify that by dividing everything by 6. So the answer would be 1 to 2 to radical 3 plus 2. And that's the best answer we could write. Okay? Moving on. Here's your 10-9, number 9, part A. We are asked in this question, as I flip through, we are asked to find the length of this arc. Okay? We want to find the length of arc AB. In order to find the length, I need 2 pieces of information. I need the radius, and I need the central angle, or the degree measure of the arc. Okay? In this problem, the radius is 18. Can you envision that? I disagree. 18 is the radius. Does everybody agree? No? Why? Oh, I see. Okay, hold on. Got it. AO is the radius. Okay. So, what we've got is, we've got the hypotenuse of a 30, 60, 90 triangle. Okay? So, that's going to be 60, 30. That makes this 9. And this whole thing is 9 radical 3. Now, keep in mind, this is 9 right here, right? This is 30. So now, to get from the long leg to the short leg, I got to divide by radical 3. So that's 9 divided by radical 3, which is 3 radical 3. So this part, I need my letters. I'm sorry. There are no letters. Let's call this Z. All right, here's what I found. AZ, I made up the Z, is 9 radical 3. Does everybody understand that? What is OZ? What did we just find OZ to be? We got it to be 3 radical 3. And we used this triangle here to find that OZ was 3 radical 3. I went from 9 and I divided by radical 3. So OZ is 3 radical 3. So then what is OA, our radius? It's 6 radical 3. So now we know our radius is 6 radical 3. Our central angle is not 60 degrees. Our angle is this thing. Do you guys understand that? 120. And so to find that, I'd have to go, this is 30, and this is 30. This is a 120 degree arc. Wow, they're really giving you the hard question first here, number 9. Okay? So, we know that arc AB is 120 degrees, and we know that the radius AO is 6 radical 3. So, the arc length is going to be 120, the arc measure, divided by 360, times the circumference, which is pi times 12 radical 3. Do they want us to estimate this? Nope. They want us to simplify it. So, that's a third, and a third of 12 is 4, so you get 4 pi radical 3. And that is the answer. Okay, that's a good problem. You might have to rewatch that and slow it down. If you're not willing to write out your own picture here, or maybe a couple pictures, then it's going to be a very difficult problem to solve. So those of you that tend to not Widmapoi might have a problem with that. Now, the only thing I want to fix is this original picture that I drew was wrong. I was drawing this problem under the assumption that 18 was the radius. It's not. So this thing actually, that circle would look like that. That's what the circle would look like. Okay? Boom!